be solving systems of equations in two variables. And what we really are going to focus on are two lines. What happens when we have two linear equations? Well, there's only three things that can happen when we have two lines. First of all, the two lines could intersect. If the two lines intersect, that means they cross or they meet at a particular point, at only one point. That point, which is the point of intersection, we are going to say is the solution to the system. Okay, so the fact that they cross at exactly one point, this point is going to be the solution to the system because it is the point that they both are going to share, they're going to have in common. We call a system that has a solution consistent. The fact that it has a solution, we're going to call this consistent. The fact that the two lines are basically independent of each other, this is called consistent and independent. I can tell right away that two lines are going to cross because their slopes are going to be different. So any system where you have two lines, two linear equations, and you have different slopes, automatically those two lines have to intersect. And sometimes students get confused and they think, oh, perpendicular lines. Perpendicular lines are an example of intersecting lines. And yes, they're going to have one solution because they're going to have one place where they meet. But it's not necessarily all lines that intersect are going to be perpendicular. Okay, so right now, if you take two lines and they cross, they're going to cross at exactly one point. We're going to call that system consistent and independent. And I can tell right away if I see the equation written in y equals mx plus b slope-intercept form, as long as they have different slopes, I know that they're going to cross. What else can happen between two lines? The two lines can be parallel. If the two lines are parallel, that means that they never intersect, they never cross. Because they never intersect and they never touch, that means that there is no point of intersection. That means that there is no solution to the system. If you remember earlier, I said the word consistent means that there is a solution. So the fact that parallel lines have no solution means that this system is inconsistent. And if the system is inconsistent, that is it. That's all we say. It is inconsistent. How can I determine without even graphing that these two lines are going to be parallel? Well, in the form y equals mx plus b, these lines are going to have exactly the same slope, which is going to make them parallel as long as the y-intercepts are different. So if the y-intercepts are different, but they have the same slope, that means these two lines are going to be parallel, and parallel lines are going to have no solution. The system is called inconsistent. The third thing that can happen when I have two lines is that one line falls exactly on top of the other. We say that we're graphing the same line. I can tell right away that I'm going to have the same line if I have exactly the same slope and I have to have the same y-intercept. So if I have the same slope and I have the same y-intercept, obviously this has to be exactly the same line. So because I have one line on top of the other, how many times do those lines meet? How many points of intersection do they have? They have infinitely many points of intersection. They touch all the time. So we're going to say that there's infinitely many solutions. And just like before, this system is consistent because it has solutions, but this time it is consistent and dependent because in order for one line to fall exactly on top of the other, they have to be dependent on each other. So right here in front of you, you have the only three things that can happen when you have two lines. The two lines will cross, they'll intersect at exactly one point. That point of intersection is called a solution. The system is called consistent and independent. And I can tell right away if they have different slopes that is going to happen. Or I can have two lines that are parallel. In this case, there's no solution to the system. We call this system inconsistent. And we can tell right away if they have the same slope and different y-intercepts, that the lines are going to be parallel. And lastly, we know that we're going to be graphing the same line when I have the same slope and the same y-intercept. And in this case, they're going to touch infinitely many times. So we say that there's infinitely many solutions, and the system is called consistent and dependent. Let's check out some of the problems to see what they ask us for. Directions. Solve the system by graphing. So in question number 1, we are supposed to solve the system by graphing it. So 2x plus 5y equals -2. The first equation is not in slope-intercept form. So one of the things that I want to do is work with this first equation so that I can rewrite it in y equals mx plus b form. That means we're going to go ahead and get the y by itself. So if I have 2x plus 5y equals -2, I'm going to subtract 2x from both sides. That cancels. 5y equals -2x minus 2. Divide the entire equation by 5. So now I have y equals -2/5 x minus 2 over 5. And already you must be thinking, wow, the y-intercept is -2 over 5. However, am I going to graph this? Well, -2 over 5, if you divide, is -0.4. That means that I have to go to the graph. Here's my x-axis, here's my y-axis, and I have to find -0.4, which is going to be somewhere close to the halfway mark. And then the slope tells me to go down 2 and then over 5. So from this point that I have here in purple, I'm going to go down 2, 1, 2, and over 5. 1, 2, 3, 4, 5, which is the same thing as going up to left 5. So I'm going to go up 2 and then left 1, 2, 3, 4, 5, just to get a better looking line. So there is my first line. Now I'm going to graph the second line. The second line is in slope-intercept form. The y-intercept is going to be -3 and the slope is +1 over 4. So that means I find -3 right here on the y-axis, and I'm going to go up 1 and over 4. 1, 2, 3, 4. Or I can go down 1 and left 4. So 1, then left 1, 2, 3, 4. And there's my point. Here is my line. So right now it looks like it's intersecting at the point 4, -2. The way we're going to check to see if this actually works is by substituting back into the equation. So the first equation, I'm going to put 2 times x, which is 4, plus 5 times y, which is -2. And we're trying to see if that really is equal to -2. 2 times 4 is 8. 5 times 2 is -10. And 8 minus 10 does equal -2. So that point actually does work for the first equation. Let's go ahead and try it in the second equation. Y, which is -2, is equal to 1/4 times x, which is 4 minus 3. So remember, we're trying to see if this is true. So 1/4 of 4, the 4's cancel. I'm left with 1 minus 3, which is -2. So it actually does work. So this answer right here is going to be the solution to my system. That means that this system is going to be consistent and independent. Okay, so that is going to be the solution to this problem. And then I want you to notice that by graphing, we were a little skeptical here to check to see if it really landed on the corner, which is why I really took the time to go back and substitute it into the equation to check. So graphing sometimes is great because we can get the answer right away, but other times we want to make sure that we check this algebraically. One of the ways that we can check algebraically is to solve by what's called substitution. In substitution, the steps that you want to take are: step number 1, choose the quote-unquote easier equation. If I take a look at this example, I have y equals -8 plus 4x, and I have x plus y equals 7. The easier equation would be y equals negative 8 plus 4x because the y is already by itself. Okay, so the first thing you want to do is kind of choose the easier equation for you to work with. Once you have made the choice of which one is your easier equation, you want to solve for one of the variables. That means get one of the variables by itself. In the one that we circled, which is our easier equation, we got lucky because we already have y by itself. We have y equals negative 8 plus 4x. If I didn't have the y by itself, then I would have had to do step 2 and then picked one of the variables to isolate. Now, step 3 is once I have a variable by itself, which in this case I have y is equal to negative 8 plus 4x, I'm going to take that information and I'm going to substitute it into the other equation. Make sure you're going into the other equation. So the other equation is x plus y equals 7. So I'm going to rewrite x plus y equals 7, but instead of y, since y is equal to negative 8 plus 4x, I'm going to replace it. I'm going to replace y. I'm going to substitute with negative 8 plus 4x equals 7. Okay, so this process is called substitution because I'm literally isolating one of the variables and then substituting that information into the other equation. So now I can go ahead and solve. So I'm going to solve for x. So here I'm going to combine like terms. Positive x and positive 4x is positive 5x minus 8 equals 7. Go ahead and add 8 to both sides. I have 5x is equal to 15. Divide by 5 on both sides. I get x is equal to 3. Okay, so once I've solved for one of the variables, I'm now going to take that information to go back and figure out the other variable through substitution again. So in this particular case, we're going to substitute into any equation to solve for the other variable. I'm going to go ahead and plug in the x where I see the x in the red equation just because there the y is already by itself. And now I'm going to solve. So y equals negative 8 plus 4 times x, which happens to be 3. So y equals negative 8 plus 12. Y is equal to 4. And then I'm going to write my answer as an ordered pair, x comma y. Even if you don't have x's and y's, usually all of these problems are in alphabetical order. So let's say the variables were m and n. You would write them in that order, m before n, because that's how they come in the alphabet, unless they tell you otherwise in the problem. So here, xy, I'm going to write 3 comma 4. And so this is my point of intersection because I have exactly one point where they intersect. If I had to, I would call the system consistent and independent. There's another way for us to be able to solve systems of equations. So let's look at this problem. Direction, solve the system by elimination. So some textbooks will call this process elimination. Some of them are going to call it the addition method. I've even seen it called cancellation. So depending on what your book used or what your teacher is calling it, but the steps are exactly the same, okay? And the point is that we want to cancel out one of the variables right away. What's great about elimination or the addition method is that you want to make sure that everything is lined up. So here in this problem, notice we have the x's, we have the y's, we have the equal signs, and we have the numbers, okay? I've done that so that you can see that right away we have everything lined up. Because everything is lined up, it's easy because what I can do right now, if you notice, I have a negative y and a positive y. If I add these two equations together, I'm going to cancel out the y's. So x plus x is 2x, 10 plus 6 is 16, and very easily I can go ahead and get the x by itself. X is equal to 8. Look how fast that happened, okay? A lot faster than if I were to try to do substitution in this particular example. So what do I do with x is equal to 8? You have to go back to any of the equations and you want to solve. I'm going to go ahead and choose the second equation this time around. X plus y equals 6. And I'm going to replace the value of x with 8. So 8 plus y equals 6. If I subtract 8 from both sides, that means y is equal to negative 2. And finally, I write my answer as 8 comma -2. So that's my solution. Because I have exactly one solution, remember we're going to call this system consistent and independent. So what are the steps for elimination? Step 1, make sure everything is lined up. That means check that the x's, the y's, the equal signs, and the numbers are all lined up. If they're not lined up, the first thing you're going to have to do is rearrange the variables and rearrange everything so that everything is nicely lined up. The second thing that you want to do is choose the variable that you're going to cancel. Ideally, you want to choose the variable that has the same coefficient in front. One of them has to be positive, one of them has to be negative. And so in this problem, we actually had negative y and positive y, which made life so easy because we could cancel them right away. But you're going to see that there are going to be times when you don't have that. And so you're going to have to use multiplication so that you can change the problem into another equation that you can then go ahead and cancel out. So we're going to do that in the next example. Once we're done, we're ready to solve for the variable through addition. So once you have the same coefficient in front of the same variable, one positive, one negative, you can cancel that variable. By addition, you're going to solve for the other variable. And then finally, you're going to get to substitute into any equation to find the missing variable. And don't forget to write your answer as an ordered pair. Okay, so let's go ahead and try other problems. In question number 4, we have to solve the system by substitution. If you recall, the first thing we want to do in substitution is quote unquote choose the easier equation. So I don't want to pick 2x minus 5y equals 1. I know that I'm going to have to isolate one of the variables, and I have a 2 and a 5 in front. If I were to divide the entire equation by 2 or 5, I'm going to be left with fractions. And as much as I want you to know how to work with fractions, we're going to avoid them a little bit so that we don't have to, put ourselves in a position where we're making mistakes. So instead, let's choose the quote unquote easier equation, which we're going to choose the top equation. And I'm going to go ahead and solve for y, since the y is already positive and by itself. Like in the sense of that it doesn't have a coefficient next to it besides 1, of course. So here, if I have negative x plus y equals negative 5, then I'm going to add x to both sides. I get y equals x minus 5. So now that I have isolated one of the variables, I'm going to go back to the system and I'm going to substitute this into the other equation. Okay, make sure you're plugging into the other equation. That's so important. If not, then you're bound to make a mistake. So then here, 2x minus 5y, I'm going to rewrite this as 2x minus 5 parentheses, y is x minus 5 is equal to 1. So I distribute 2x minus 5x plus 25 is equal to 1. 2x minus 5x is negative 3x plus 25 is equal to 1. Subtract 25 from both sides. I get negative 3x is equal to negative 24. Divide by negative 3, and now x is equal to positive 8. Okay? So now that I have x is equal to positive 8, since I already started by getting the y by itself here, it only makes sense to go back to that equation to figure out the value of y. So y is equal to x minus 5, x is 8, 8 minus 5 is 3. That means y is equal to 3. My solution is 8 comma 3. It's always x comma y. And we really haven't been doing this in the other problems, but one of the ways that you can check to see if you are correct is by taking the time to substitute your solution into the equations. So let's go ahead and try that right now. We have negative x plus y equals negative 5. Here's x, here's y. This means negative 8 plus 3 equals negative 5. That is true. Let's go ahead and substitute into the second equation. 2 times x, which is 8, minus 5 times 3, which is y, is equal to 1. This is 16 minus 15 is equal to 1. That is also true, so I am confident that this is in fact my solution. And because I have exactly one solution, I am going to call this system consistent and independent. In number 5, we're going to solve the system by elimination or the addition method. If you notice, the first thing that we have to do is check very quickly that everything is lined up. So the x's are lined up, the y's are lined up, the equal signs are lined up, and the numbers are lined up, which is great. That means that I can go ahead and proceed with the problem. So now I have to make a choice. Which variable do I want to cancel? If I look at the x's, I have 2x and 3x. They're not the same coefficient. I wanted one to be positive, one to be negative, and right now they're not. So I would have to multiply basically the top equation by, let's say, 3, the bottom equation by -2. And that's one way that I can actually solve this problem. The other way that I can solve this problem is to look at the y's. This y has a -7, this y just has a 1. In this particular case, I can make the bottom one +7 if I multiply the entire bottom equation by 7. And so I'm going to go ahead and do that. You could also have done what I said first with the x's, and you're still going to get the same answer. I'm going to go ahead and multiply by 7. This becomes 21x plus 7y equals -140. I'm going to rewrite the top equation, 2x minus 7y equals 2. Try to take careful attention to keep everything lined up, your x's, your y's, your equals, and your numbers. I draw a line because I'm going to be using the addition method to add the two equations together. They cancel. 2x plus 21x is 23x is equal to -138. I divide by 23 on both sides, and I get x is equal to -6. Now that I know that x is equal to -6, I can go back to any of my equations and I can substitute. So I'm going to have 2 times -6 minus 7y is equal to 2. All I did was use the first equation. I just happened to pick the first one. You could have picked the second one. -12 minus 7y is equal to 2. Add 12 to both sides. I get -7y equals 14. Divide by -7. So y is equal to -2. So that means that my solution is -6, -2. And I can always check this really quickly by substituting it back into the equation. So 2 times -6 minus 7 times -2, does that equal 2? This is -12, negative is a +14, and -12 and +14 does equal 2, so that is correct. In the bottom equation, 3 times x, which is -6, plus y, which is -2, is equal to -20. This is -18 minus 2, and that does equal -20, so I'm confident that this is, in fact, my solution. In number 6, we're also solving by elimination or the addition method. We are always going to start addition method by checking that the x's are lined up, the y's, the equals, and the numbers. If not, you definitely need to rearrange everything first. Once that we have checked that and everything is okay, we have to decide which variable we're going to cancel. Right now in front of the x's, I have a 2 and a 5. In front of the y's, I have a 3 and a -10. So it's not going to be as easy as the previous question where all I had to do was multiply one of the equations to make them have the same coefficient. In this case, I'm going to have to multiply both equations. And this time again, you have a choice. If you notice, the y's, one is positive and one is negative, which is always good news because that means that it'll eventually cancel once I make them have the same number. So I'm going to go ahead and choose the y's to work with. If you choose the x's, no big deal, but just realize you are going to have to make one of the numbers that you multiply by going to be negative, meaning I could multiply the top by +5, but then the bottom by -2. Or instead, I would have multiplied the top by -5 and then the bottom equation by +2, as long as one of them is going to be negative. But I'm going to go ahead and choose the y instead. So I'm going to multiply the top equation by 10 and the bottom equation by 3. So you might be asking yourself, am I just switching the numbers one on top and one on the bottom? And the answer is kind of like yes and no. No, you don't necessarily have to put the same numbers if you were to find a least common multiple for both of them that's smaller. But yes, it is going to work if this is what you do. Okay, if you're one of those people that just show me an easy way to do this, then go ahead and just multiply by switching the numbers around. So then we're going to go ahead and distribute. I get 20x plus 30y is equal to negative 160 in the top. In the bottom equation, I get 15x minus 30y is equal to 90. I draw a line. The y's cancel. We're adding. Remember, this is the addition method. So I get 35x is equal to negative 70. If I divide by 35 on both sides, then x is equal to negative 2. All of these are coming out to be beautiful. So then 2x, I'm going to go ahead and substitute into either equation. I just so happen to pick the first one. I'm going to replace x with negative 2 because that's what I got when I solved. So 2 times negative 2 plus 3y equals negative 16. Negative 4 plus 3y is negative 16. Add 4 to both sides. 3y is equal to negative 12. So y is equal to negative 4 when I divide. So my answer is negative 2, comma, negative 4. Let's go ahead and check by substituting back into the equations. 2 times negative 2 plus 3 times negative 4. We have to check to see if that is equal to negative 16. Negative 4 minus 12 does equal negative 16, so that works. Then we have 5 times negative 2 minus 10 times negative 4, and we're checking to see if that's equal to 30. Negative 10 plus 40 is equal to 30, and that is true. So yes, I am confident that this is in fact the solution to my system. Last but not least, number 7, fractions, okay? What happens now? How do you do these problems? Well, if you're like my students who do not like to work with fractions, I would highly recommend that the first thing you do for each of the equations is to identify the least common denominator. Multiply the entire equation by the least common denominator, and then you're going to get new equations that you can solve as normal. So that is going to help you avoid making mistakes, especially if you don't like fractions. So let's start with the top equation. The least common denominator is 6. So I'm going to multiply each part of the equation by 6. So 3 goes into 6 2 times. I'm left with 2x. The 6's cancel, plus y. And then 3 times 6 is 18. In the bottom equation, the least common denominator is 4. So I'm going to multiply the entire equation by 4. Every part by 4. And you don't have to do it like that. You can actually just put a huge parentheses and put the 4 in front. I do it this way so you don't forget that it has to be distributed to every single part. So 2 goes into 4 2 times. I'm still left with 2x. The 4's cancel. Minus y is equal to 4. And look at what we have right now. We have completely eliminated the fractions. We're left with a system of equations that we're going to solve by elimination, where we can totally cancel out the y's right away. It's actually fantastic. So by addition, I'm going to cancel out the y's. I have one positive, one negative, and then I'm going to be left with 4x is equal to 22. Go ahead and divide by 4. So 22 divided by 4 is 5.5. So now that I know that x is equal to 5.5, I can go to any of the equations and I can go ahead and solve. I can actually grab one of the new equations. So 2x plus y equals 18. The x is 5.5. 2 times 5.5 plus y is equal to 18. 2 times 5.5 is 11. If 11 plus y is equal to 18 and I subtract 11 from both sides, I get y is equal to 7. So then my solution is going to be 5.5, comma 7. Can I check to see if this is correct? Absolutely. Let's go ahead and substitute. 5.5 divided by 3 plus 7 over 6 is going to equal 3. So take your calculator and go ahead and put 5.5 divided by 3 plus 7 divided by 6, and it's going to give you 3. Yes, it works. Let's try the next one. 5.5 divided by 2 minus 7 over 4. Does that equal 1? Again, you can put it in your calculator just to check. 5.5 divided by 2 minus 7 divided by 4 does equal 1. So yes, this is my answer. I hope you found this video helpful. Remember to subscribe to my channel for more help with math so that you can say, yes, I can do math with confidence. Until next time, thanks for watching.